We are standing at the threshold of a post-antibiotic era. Our most potent weapon against infections is losing its edge. In today's episode of Health Matter, we delve into the pressing issue of antibiotic resistance, uncovering the strategies that scientists and healthcare professionals are employing to combat this global menace. Join us as we explore groundbreaking research, innovative treatments, and practical steps you can take to contribute to the fight against antibiotic resistance. Welcome to Health Matter. If you're passionate about health and eager to stay updated with the latest in medical research and wellness tips, be sure to subscribe to our channel. Hit the notification bell to never miss an episode, and don't forget to like and share our videos to help disseminate vital health information. Antibiotic resistance occurs when bacteria evolve to withstand the drugs designed to kill them. This makes infections harder to treat and can lead to severe health complications. Essentially, bacteria develop mechanisms to survive even in the presence of antibiotics that once wiped them out. This is not about our bodies becoming resistant, but the bacteria themselves adapting. When antibiotics are overused or misused, such as taking them for viral infections like colds or flu, bacteria are exposed to these drugs frequently. This exposure can lead to mutations and the survival of resistant strains. Imagine trying to surprise a friend with the same trick repeatedly; they'll eventually catch on. Similarly, bacteria learn to dodge the effects of antibiotics. The rise of antibiotic resistance is a global health crisis. According to the World Health Organization, resistance rates among common bacteria like E. coli and Staphylococcus aureus are alarmingly high, with some antibiotics losing effectiveness in over 40% of cases. Infections that were once easily treatable are now becoming dangerous, increasing medical costs and mortality rates. In 2019 alone, antibiotic-resistant infections directly caused 1.27 million deaths worldwide, highlighting the urgency of addressing this issue. As bacteria continue to evolve, the need for new antibiotics and better stewardship of existing ones becomes more critical. Antibiotic resistance is a critical global health crisis, affecting public health and the economy on an unprecedented scale. The rise of antibiotic-resistant infections poses a severe threat to public health worldwide. In 2019, antibiotic-resistant infections were directly responsible for 1.27 million deaths and contributed to nearly 5 million deaths globally. This growing resistance means common infections, such as pneumonia, tuberculosis, and urinary tract infections, are becoming harder, and sometimes impossible, to treat. The economic burden of antibiotic resistance is staggering. By 2050, it's estimated that antimicrobial resistance, AMR, could cost the global economy up to $100 trillion. Healthcare systems are under immense strain, with longer hospital stays, more intensive care, and the need for more expensive treatments. This not only increases healthcare costs but also leads to significant productivity losses as individuals are unable to work due to prolonged illness. The crisis extends beyond human health. The overuse of antibiotics in agriculture and the release of pharmaceutical pollutants into the environment contribute to the spread of resistance. This misuse in livestock and crop production leads to resistant bacteria entering our food supply and environment, further exacerbating the problem. Tackling antibiotic resistance requires a global, multi-sectoral approach. International organizations are working together to promote better stewardship of antibiotics, enhance surveillance of resistant infections, and invest in the development of new antibiotics and treatments. Public awareness and responsible use of antibiotics are crucial steps in this battle. Antibiotic resistance is driven by several key factors, each contributing to the escalating global crisis. Let's break down the primary causes. The overuse and misuse of antibiotics in human medicine are major contributors to antibiotic resistance. In the U.S., at least 30% of antibiotic prescriptions are unnecessary. This often happens when antibiotics are prescribed for viral infections, like colds or flu, which they cannot treat. Such misuse allows bacteria to be exposed to these drugs without being eradicated, fostering an environment where resistant strains can thrive. When patients do not complete their prescribed antibiotic courses, some bacteria survive and develop resistance. These resistant bacteria can spread to others, making future infections harder to treat and increasing the risk of severe health complications. The use of antibiotics in agriculture is another significant factor. Over half of the antibiotics produced globally are used in animals, often to promote growth and prevent disease in healthy livestock. This practice is particularly common in intensive farming settings. Antibiotics used in animals can lead to resistant bacteria in their gut, which can then spread to humans through the food chain, water, and direct contact. This not only affects people who consume animal products but also contributes to environmental contamination, making resistance a widespread issue. Another critical factor is the lack of new antibiotics being developed. Over the past few decades, the pharmaceutical industry has significantly reduced its investment in new antibiotic research due to high costs, complex regulatory requirements, and relatively low financial returns compared to other drugs. Since the 1980s, very few new classes of antibiotics have been brought to market. This stagnation means that as bacteria become resistant to existing drugs, there are fewer new treatments available to replace them. This growing gap highlights the urgent need for renewed focus and investment in antibiotic research and development. Antibiotic stewardship programs are crucial in hospitals to ensure the effective use of antibiotics. These programs involve a team of healthcare professionals, including doctors, pharmacists, and infection control specialists, who work together to monitor and guide the appropriate use of antibiotics. The goal is to minimize unnecessary prescriptions and to use the right antibiotic at the right dose and duration. Educating both physicians and patients about the dangers of antibiotic misuse is essential. Doctors are trained to distinguish between bacterial and viral infections and to prescribe antibiotics only when absolutely necessary. Patients are encouraged to follow the prescribed treatment regimens strictly and to avoid demanding antibiotics for conditions like the common cold or flu. Implementing strict regulations to prevent the sale of antibiotics without a prescription is another critical step. In many countries, over-the-counter sales contribute significantly to misuse and overuse. By ensuring that antibiotics are only available through a doctor's prescription, we can reduce the risk of developing antibiotic resistance. Preventing infections in the first place reduces the need for antibiotics. Basic hygiene practices, such as regular hand washing and maintaining clean environments, play a significant role in controlling the spread of infections. Improved sanitation systems also help reduce the incidence of bacterial diseases. Vaccinations are a powerful tool in preventing bacterial infections. Vaccines for diseases like pneumonia and whooping cough reduce the need for antibiotics by preventing the infections from occurring in the first place. Increasing vaccination coverage can significantly reduce the burden of antibiotic resistance. The development of new antibiotics is crucial in the fight against resistant bacteria. Despite the high cost and lengthy process, investing in new antibiotic research is essential to stay ahead of evolving bacterial threats. Many global health organizations are calling for increased funding and collaboration in this area. Besides new antibiotics, alternative therapies like bacteriophages, which are viruses that target and destroy bacteria, and monoclonal antibodies, which can enhance the immune response against infections, are showing promise. These innovative treatments offer hope for tackling resistant infections when traditional antibiotics fail. Artificial intelligence, AI, is revolutionizing drug discovery. By using AI to model and predict how new compounds will interact with bacterial cells, researchers can speed up the identification of potential new antibiotics. This technology helps in efficiently screening thousands of compounds, significantly shortening the time required to find effective treatments. Implementing strict regulations on the use of antibiotics in agriculture is essential. Overuse in livestock and farming contributes to the spread of resistance. Policies that limit antibiotic use to therapeutic purposes only and ban the use of antibiotics for growth promotion can help reduce this risk. Governments can play a crucial role by providing incentives for pharmaceutical companies to develop new antibiotics. Grants, tax breaks, and extended patents are some of the strategies being used to encourage innovation in this critical field. The One Health approach recognizes the interconnectedness of human, animal, and environmental health. By addressing antibiotic resistance across these sectors, we can implement more comprehensive and effective strategies. This includes improving antibiotic use in veterinary medicine, reducing environmental contamination from pharmaceuticals, and ensuring coordinated efforts across public health, agriculture, and environmental policies. Recent advancements in antibiotic research are providing new hope in the fight against resistant bacteria. Let's take a look at some of the most promising innovations. Researchers at Harvard University have developed a new synthetic antibiotic called chrezomycin. This drug is designed to bind tightly to bacterial ribosomes, overcoming common resistance mechanisms. In animal tests, chrezomycin was effective against several drug-resistant strains, including Staphylococcus aureus and Escherichia coli. This innovation demonstrates the critical role of structural biology in designing next-generation antibiotics. At Vanderbilt University, scientists discovered a groundbreaking compound named ARM1 that inhibits the genetic mutations responsible for antibiotic resistance. By targeting the DNA translocase MFD, ARM1 slows down the development of resistance across various bacterial pathogens. This compound could be combined with traditional antibiotics to enhance their effectiveness and prevent resistance during treatment. In addition to new antibiotics, alternative therapies are being explored. Bacteriophages, viruses that infect and kill bacteria, and monoclonal antibodies that boost the immune response are showing promise in preclinical studies. These therapies offer new avenues for treating infections that no longer respond to conventional antibiotics. Artificial intelligence is revolutionizing the way we discover new drugs. By using AI to model and predict interactions between drug compounds and bacterial targets, researchers can expedite the identification of potential new antibiotics. This technology enables the screening of thousands of compounds in a fraction of the time required by traditional methods. Combating antibiotic resistance starts with individual actions. Here are some key steps you can take to help in this fight. Always follow your doctor's instructions when taking antibiotics. Never demand antibiotics if your doctor says you don't need them, and never use leftover antibiotics or share them with others. Proper use ensures that these medications remain effective for treating bacterial infections. Good hygiene can prevent infections and reduce the need for antibiotics. Wash your hands regularly, especially before eating and after using the bathroom. Proper sanitation and food handling practices also help prevent the spread of infections. Vaccinations are a powerful tool in preventing bacterial infections. By staying up to date with recommended vaccines, you can reduce your risk of illness and the need for antibiotics. Public awareness about antibiotic resistance is crucial. Understanding the dangers of misuse and overuse helps foster responsible behavior. Support and participate in educational campaigns to spread the word about the importance of preserving antibiotic effectiveness. Antibiotic resistance is a critical global issue that threatens our ability to combat infectious diseases. Without effective antibiotics, we risk a future where simple infections can become deadly. But there is hope. Through responsible use of antibiotics, good hygiene practices, vaccination, and continuous research and innovation, we can turn the tide against antibiotic resistance. Every action counts, and together, we can ensure a healthier future for all. Thank you for joining us on Health Matter. Stay informed, spread awareness, and take action to combat antibiotic resistance. Don't forget to subscribe to our channel, hit the notification bell, and share this video to help us spread the word. Together, we can make a difference.